Welcome to the Glassworking shop. Well, I'm continuing the experiment of this intersecting circle geometry pattern, and I've cut the resized pulled pieces into slices on the wet saw and assembled them onto the ceramic plate for chip stacking. This is a still photograph showing how they fit together. Because the pulling, first of all, they were just pulled by hand, and second of all, it's just the inherent nature of pulling glass that they pull the way they feel like pulling, and they're not geometrically perfect. The corners are rounder than I'd like, the sides are not as flat as I'd like. I'm probably going to experiment with squeezing the smaller sizes, but what I've found in the past is that attempting to squeeze a very small size is troublesome because the glass loses all of its heat. Even if I'm torching it like right next to the squeezer and put it in as fast as I can, the glass is cold by the time it hits the squeezer. So anyway, I'm going to attempt to chip stack assemble using my experimental prototype chip stack assembly kiln rig thingy that I don't have a cool name for yet. But anyway, I'm going to attempt to chip stack it together to the best of my ability and see if the pattern actually looks good when I'm done. And then I'm going to attempt to roll it up. And the roll up will be a little more challenging because it's not made out of squares, it's made out of triangles. So I'm going to head over here to the assembly rig. And I'm going to be using, as I always do, using the Mirage hand torch. I'm going to be using a kind of a smaller oxidizing flame. I've found that this gives me a better result. So here goes. Put the work area in the camera frame. Of course, doing this work is somewhat challenging. Trying to do a reasonably complex piece of glass work for the first time. Experimenting, inventing, learning, while making a video and improvising narration. Hey, why not take something hard and try to make it harder? First step is just to get the chips to stick together, which is rather challenging. Because there's a lot of them and they're small and they're irregular and they don't fit that well together. Also, I think I'm having a bit of problem with the pattern sticking to my substrate here. I think because there's so much white in it, white may be a more challenging color to deal with. So it's all R&D, it's all experimental. I'm just trying to get a better angle on it so I can possibly, there we go. When it aggressively sticks to the plate, it's pretty much game over. When it sticks but good. And the challenge in this process is to get the chips to stick without sticking to the plate. Yep, this is not coming out well at all. I think once I actually successfully did a triangular chip stack using small triangles before. But it was not easy. I'm not exactly sure, since all of this is new and experimental. But it seems like these chips are sticking a little more easily and aggressively than other patterns. I think that white is a more difficult color to work with as far as sticking. From what I understand about the construction of white is that it's basically clear with some kind of top secret mineral kind of stuff when I asked Abe, hey, what's in Star White? He didn't give me a very good answer. I think it's a secret. Which is okay. I have no interest in making my own color, and I'm perfectly happy buying North Star color. But he did, even though he didn't tell me exactly what the components were, he kind of told me that it was clear with kind of whitish stuff mixed in. So this is not going as well as I expected or hoped. And the pattern is not coming out as nice as I hoped. Definitely getting a lot more sticking problems. I'm trying to get it away from the sides because even though the sides are great for initial alignment and final alignment, they also tend to act as heat sinks and kind of suck a lot of the heat away. So in order to get good fusing on the outside edges, I need to get it away from the edges. It's moving around pretty good now. Of course, the question arises, other than just being curious and experimenting, if your goal was to create this pattern in a geometrically perfect way on the surface of a round object, I believe that the sandblasted growl technique probably produces a lot better results. And the limitations of this technique may be so much that it may not really be useful for anything. But still, it's fun to experiment and just try to figure out, well, hey, what can I do with this? Is there a variant of this technique that hasn't been explored yet that might be useful? But what I'm noticing now, it's exceptionally difficult to avoid sticking to the plate. I'm not getting very good geometry. It seems like the more I attempt to fuse the chips together, the more distortion I introduce in the pattern. Definitely having a very annoying problem with sticking to the plate, even though when my tweezers are getting hot too. Even though I coated the plate with the Bullseye shelf primer, that has not really been effective in preventing sticking. Also, the geometric unevenness of the chips means that as I attempt to consolidate them, squeeze them together, it's introducing more and more distortion. So I'm not optimistic at all that this is going to be a great success, but I'm not going to give up. One kind of piece of good news as I'm working, I'm not seeing a whole lot of evidence of boiling or other surface degradation. The glass pretty much looks happy with what I'm doing to it, but the pattern most definitely is distorting. And also, this geometry just on its own, the kind of parallelogram constructed of triangles, is a challenging geometry to deal with just by its nature. So, welcome to the R&D lab, where nothing is easy. definitely not getting a clean pattern at all. Using a very finely focused flame to try to close up some of the holes. It's interesting that it appears that the radiant heat coming off the surface of the work is actually affecting my torch flame. Take it away, it's nice, put it into position, starts getting a little squirrely. Yeah, definitely if I ever try this method again, the individual triangular components are going to need to be a lot more precise. Actually, the back looks quite a lot better than the front. So, I'm going to put the pieces back in the kiln for a few minutes, let them reheat. And then when I come back, I'm going to continue the process, even though it's not coming out super well. The pattern, the more I work with it, the more distorted it gets. And so it may turn out that this is the wrong approach, or maybe I'm just doing it wrong. Maybe it's a fine approach if I just figured out how to do it. My suspicion is that the little triangular components need to be much more precise. Either resized in the squeezer, cold worked, or in some other way made so that there's almost no gap, because as I try to fit together these irregular shaped pieces, the distortion starts to dominate the pattern. So I'm going to turn off the camera for a few minutes and wait for it to reheat and then come back. Well, I'm back again. Let's see if I can get something out of this thing, even though it's not coming out as nice as I would like. The back side definitely looks a little better than the front side. I think it actually might work really well if the pieces were just more precise. I think the problem that I'm having is that the pieces are not quite precise enough, and unlike some of my other work where accuracy kind of doesn't matter and just letting the glass flow like it flows and being pleasantly surprised by the result is a good thing, in this case, because it's such a well-known pattern that requires fairly good geometric perfection, it just may turn out that this is the wrong approach. But you never know till you try. It's actually not sticking super bad. And of course I realize that trying to achieve geometric perfection in glass is rather difficult. There are very few techniques and processes that produce perfection, and it's becoming painfully obvious this is not one of them. So you know what? I think I'm gonna just proceed to the next step. And I'm gonna change the shop setup a little bit. Need to move over to the NQALHA bench and prepare for the roll-up. Okay, I'm also kind of still working on figuring out how to do my camera setup. I didn't quite have the setup correct for being able to switch between workstations. So, oh well, let's see if I can do a roll-up. The camera on the Chipstack rig has now been deactivated, so not going to be able to see the unbelievably uninteresting part of picking up the stack. So let's hope this thing stays together until I get over to the other workstation. Kind of preheat my tongs a little bit so that I don't overshock my piece. Then somewhat of a challenging balance here. I want my hunty weld to be strong enough that I don't lose my piece, but I don't want it to be so strong that it digs into the pattern. Of course, like I always do, I'm trying things that are way beyond my skill level. Even though I haven't yet mastered simple roll-ups, now I'm trying a parallelogram roll-up. I must be crazy. But throughout my work in engineering and craftsmanship and fabrication and all the other things I've done, I've always tried things beyond my skill level. Sometimes actually even made them work. Sometimes actually even accomplished a bit of success. And yes, this is substantially more difficult than the already difficult roll-up procedure. I must be crazy. Well, I think it's stuck together, kinda. more or less. Now, I'm going to see if I can kind of circularize it. Just gently and slowly. And just coerce it into some kind of a roundish kind of shape. One thing I'm noticing, that white is a softer color, and my previous roll-ups have been made of stiffer colors, and so this one appears to be softening a little bit easier, but of course, because it's such a weird combination of shapes, I wouldn't say it's easier to work with. And I know I've said this many times before, but I'll say it again. Now, why do I make these videos? Well, because video making is fun. I enjoy it. I've been a photographer for years and just find the whole process to be kind of fun. And you know, some people might ask the question, well, you're obviously not a master. Why are you making videos? Only masters should be allowed to make videos. And while I think there may be a tiny bit of validity in that statement, I also think that, you know, seeing the process, seeing the learning process of fumbling in ignorance and slowly, step by step, gaining proficiency may actually be educational for somebody, especially somebody who is learning glasswork, and they may find it informative to watch me go through the process and have problems and figure it out. None of the masters started as a master. One of my favorite quotes that, I don't know where it came from, it's probably something Asian or Buddhist or something, the master has failed more times than the student has tried. It may actually be informative for a student just to watch the process of inventing. And when I say inventing, I'm not taking credit for being the first glassworker to do a roll-up. That would be really ridiculous. But I am inventing the squeezer, the Chipstack assembly fixture, and trying to figure out techniques that might be reasonable for use with these tools. So this end is approaching roundishness, somewhat roundish. Trying to keep my punty attachment point hot enough to not explode and fall off, but at the same time, if I get it too hot, it gets limp. Boy, I nailed that size. I pre-made these little clear cups. Didn't show that on the video. Maybe I will someday. Maybe I'll show the entire process, but at the moment I'm using a pre-made little cup. Okay. Well, that has very definitely increased the stability of this very unstable assembly. Try to make sure that it stays on center here. Now I'm gonna get rid of Mr. Punty. Hopefully not muck things up too badly as I get it off. Substantially more stable, but still unstable. Yeah. Blow tube just came out of the kiln. The glass is looking happy. I'm not seeing signs of boiling. It's looking more or less happy, more or less kind of shiny. It actually, the glass itself appears to be behaving a little bit better than my darker colored roll-ups. So there's the hot shot of what it looks like at the moment. Now I'm going to get my little cup out of here, my little pre-made cup, and once again I hit my target size dead on. Must be getting a little better at this. Get rid of Mr. Punty. So now I'm gonna melt it in, blow it out, condense it down, and at my current skill level, I do this better one-handed. Definitely behaving a bit differently from my darker color pieces. I'm going to take it out of the flame. I'm using a bit of gravity here to let it elongate a little bit because it appears to have shortened a bit during the assembly process. And no, I'm not comfortable doing this on the NQALHA. I suspect it's possible to do, but not at my current skill level. Now, I'm probably going to reverse axes on this guy because it's exceptionally difficult, maybe impossible. The really good glassworkers I've seen, my teachers and the other good glassworkers I've seen frequently reverse axis when they're doing this kind of work. So I've got a pre-made blow tube. It's really, really hard to melt in the side that's close to the punty because, you know, the punty just gets soft. So here I'm popping a hole in the NQALHA. Now I'm going to be using the push-pull-blow technique. So get both mating surfaces ripping hot. I've got an earplug in the end of the blow tube I'm going to be welding on. Going to push, pull, and blow. Then give it a little more heat, take it out of the flame, make sure everything's on center. As I was doing the right side, there's always a chance the left side was getting cold. So once again, you don't want to fixate. Be concentrating on one part so much that you forget about another part. And when you forget about things in glasswork, they get cold and crack. And for those that don't know, a smoky propane flame deposits a little bit of soot on the glass, and turns out that a kind of a happy accident or coincidence that the soot burns away right about at the annealing temperature of the glass. And so you get your annealing flame going, get soot on your workpiece, and then when the soot burns away, you know you're good. You know your piece is happy. So I'm going to tear off a little bit. There's a little too much glass on this end. Now, switching to handwork. Out of the flame, let it relax for a minute, kind of equalize. Give it a tiny little puff. That's one thing I learned. There's not much blowing in glass blowing. A lot of it is tiny puffs. And yes, I know there are times when, under certain conditions, for certain effects, you have to blow hard. But in a lot of cases, tiny puffs are the answer. I'm mostly working on developing the ability to do shaping with flame, gravity, and air, and kind of avoid marvering, but you know, sometimes it's just what you need. Okay, so the pattern is definitely, it's softer than the colored glass. So here's what it looks like at the moment. Now, I'm gonna keep it warm over here and go get a tool. I'm gonna be using my U-marver here. Okay, so the adjustable handheld U-marver has now been set to the correct diameter, and this guy is way too big, so I'm going to need to condense it down a little bit. Condensing is a tricky operation. I have not mastered it by any means. But I do understand the theory behind it, that you need to get the glass soft enough that surface tension starts to have an effect. And of course the Marver helps a little bit, but true condensing is really all about getting it hot enough for the surface tension to have an effect, but not so hot that you lose control and it gets all loose and floppy. So, which is why technique is so important, and finding that perfect balance. Oh no, that's a nice size. So now I'm just heating it up barely enough to let it move a little bit. And just blowing very gently. Until I can barely feel it dragging. This part is the kind of scary part. This can easily get out of control. And you know what? I am gonna call that close enough is good enough for today. I realize that I was probably going to need to put a light up there so I can show the glass pieces on this camera. Not great, but not horrible either. So, another highly experimental, didn't fail catastrophically, didn't come out as good as I'd like it to, somewhere in between, but hey, that's what R&D is all about. That's what learning is all about. And anyway, thanks for watching. It's been fun.